Hi folks, hope you're all keeping well out there. I'm back with another video, and this time it's going to be around hosting various services from home. So I'm just showing you here briefly under Portainer the easy way you can install various Docker images for numerous services that you can host from home. Heimdall, Homer, Jellyfin, some of these will probably be known, Maria Database, Minecraft servers, Music Brains, Nextcloud, photos, and so on. So there's quite a lot of things you can actually do. The big challenge though is the complexity. So hosting from home can be quite attractive because you basically got as much storage or Raspberry Pis as you want to put into your house. I have been hosting using a virtual private server online, but the challenge there is that you're paying for your storage, you're paying for the backup space, and it can get quite costly. It's even per CPU, the amount of RAM you're using, and the moment you're expanding past a couple of services, it starts getting quite expensive. So my plan is to keep some of my services online, but I'm going to be using more and more hosting at home. The challenge I had though with the hosting at home is that IP addresses change, it's difficult to map subdomain names through, and then to handle the SSL and so on and so forth. So today's video really is not going to be a step-by-step how to do it. There's a lot of videos showing the individual components, how they can be set up. What I wanted to really explain today more was the concept of just sort of at a high level how it fits together, because there are quite a few variables involved here. I am using Open Media Vault, for example, with Docker and Portainer to install and manage my applications. But you could be using equally well something like Proxmox or FreeNAS or some of the other types of services. And where I'm using things like DuckDNS, there's also alternatives. So again, it's up to you to decide what you want to use. I thought the idea was going to be really more just to show you how it fits together. As I'd already mentioned, there are some challenges when you're hosting from home. Primarily the network speed. You're not easily going to get around this unless you upgrade or change your ISP link. But typically what normally happens with home networks, apart from the fact your ISP says you may not host at home, there's quite a few that say that can be a small challenge. But generally speaking, your upload speed is often half of what your download speed is. So if you've got a 100 meg link, you've only got a 50 meg uplink speed. Just remember that anybody else working from outside into your house to access a service is going to be experiencing your upload speed. So if you've only got a 10 meg ADSL line, your upload may be 5 megabit, it may even be 2.5 megabits. That's the type of speed. And if you've got 5 or 6 servers running in your house, it can be very, very slow. So just keep that in mind. That could be a limiting factor. The other one, which is easier to overcome, is for any subdomain. And when I'm saying subdomain, I'm saying if your domain name is gadgeteerza.co.za, your subdomain is going to be weather.gadgeteerza.co.za, or it may be OpenWebRx. It just depends what service you've got. So those subdomains, they generally will only map to a static public IP address. Now that you typically do get with your hosting services online, part of what you're paying for also is a static IP address. So, no problem there to route to. But from home, whenever your modem reboots, or generally when it reboots or when the link resyncs or whatever, you often get a different IP address called a dynamic IP address, which changes, which suddenly means that that domain name no longer is pointing to where you want it to go. So DuckDNS obviously is an easy solution around that. I'm going to delve into just one or two aspects just to show how they do work, but I'm not going to go through each and every step. The routing of subdomains often means you're going to have lots of open ports to be forwarded via the home router. This is going to basically also mean a lot more complexity to manage on the router itself. And I can just show briefly what I mean there. So if this is your home router, every device on the network can only use one particular port for one service. So you can't have, say, 3 web services coming in from outside, all trying to access port 80. Even though the devices on the inside of your house, these over here, for example, these could be different Raspberry Pis or whatever they are, They could actually use port 80, but remember they're each going to be on their own IP address, so no problem. You can route across to an IP address port 80, IP address port 80, and an IP address port 80 if you needed to. But coming in from the outside to speak to your router, port 80 only comes in once. And your problem is going to be, how do you then split it across to where it needs to go? So typically how we get around that is we'll allocate to that particular subdomain, in this case weather.gadgeteer.co.za, I'll give it a port address 32, doesn't matter what you use, 32786. Anybody typing that full address in will come in here, and I can then forward anything that's coming in at that port number. I know it's got to go across to that address at port 80, and it'll go straight there. Over here, somebody typing in this subdomain and using that port address, the router knows if it's port address 3072, it must route it across to that IP address, in this case using, say, the same port address. So that's not going to be too much of a problem, but it does start getting a bit complex if you've got a whole bunch of devices, and especially now if you've got, say, a Docker here with a couple of containers in, each with their own addresses as well. So the solution that I've found just makes this a lot easier to make use of, and what you'll see we'll be doing when I show you the full contextual diagram, everything is just going to come in no matter what the subdomain is. It'll be coming in on port 80 or 443 as a secure SSL link, and we'll manage it from here and split it to where it needs to go to, or route it where it needs to go to. So that'll be that part we can sort out. The SSL encryption, generally people are using free Let's Encrypt, but the challenge with Let's Encrypt, it becomes quite complex. You've got to now set it up on each and every individual device inside your house. So this Raspberry Pi, that Raspberry Pi, inside this container. And also Let's Encrypt wants to call back home and retrieve its information using port 80 or 443. Challenge again is you sitting with a whole bunch of devices using those ports. So that makes things also a lot more complex and difficult to manage. And then just lastly, an extra bonus really with the solution was around login protection. So read-only servers, maybe not too much of a problem, but if you've got, there are certain services that run, say, inside Plex, and maybe one or two others, I'm not sure if Plex has got it, but if it doesn't have proper login protection, you don't want to expose that to the internet, because you've got nothing between you and the bigger internet, people just dropping in and starting to use the service. So that we can also get around fairly easily with this solution. So this is now contextually the diagram, and chiefly what we are using is the DuckDNS. And what I really found very useful and very interesting was Nginx Proxy Manager. Now this is easily installed as a container service inside something like, I'm using Open Media Vault at the moment, but like I said, you could be using Proxmox or one or two others, anything that will install Docker with something like, say, Portainer to manage your containers, no problem. You can actually install any of these things the same way that I'm doing it here. In fact, if you really want to keep things simple and you don't want Open Media Vault and Proxmox and everything running, you can, at this step over here, you can go down to as simple as just a Debian or Ubuntu server, install Docker, install Portainer, and you can do the same magic really as this. That removes all the complexity of updating and starting, stopping, and addressing and that sort of thing. So yeah, that was this part over here, and I will drill into the Nginx Proxy Manager a little bit more. Let me just explain the DuckDNS at the moment. So by the way, I've also very simplified this diagram. For example, we don't use this routing, we would have to go through here and through there, that sort of thing, and there's other gateways involved. But just for the sake of simplicity, I've broken it down into the really most simplest components. So essentially how you're going to get around things like your home IP address, which is the public side of your router over here, chopping and changing the whole time, so that if somebody types in an address like google.domain.com, it's always going to know the IP address and it'll pop through over here. We use DuckDNS for that. As in general use, what happens when you register DuckDNS, you can register for a subdomain in the front of DuckDNS. That's essentially all you can really do. So in my case, you'll see I've just got dvdmarva.duckdns.org, but you could be brian.duckdns.org. It doesn't really matter, and you can actually pick anything because you won't be exposing this as part of your service. But the important part is you're going to have DuckDNS set up also as a container, or DuckDNS, for example, will also just set up raw itself on most Ubuntu servers or Linux servers as well. Sometimes you can even set up DuckDNS on your router, in fact. So there's various ways of doing DuckDNS, but essentially all DuckDNS is going to do is it calls out from your home network to the DuckDNS server. And all it's doing is checking and reporting what your current public IP address is. That's all it does. And this subdomain here, whichever you've chosen, will resolve to that public address. So as that address changes, say tomorrow, the next day, or the next day, you can be sure that whatever the subdomain is you've got at duckdns.org, it'll always be pointing to the current public IP address. That effectively gives you what could be considered a relatively static public IP address. So that's just a general principle, and you'll find lots of videos on how to set up DuckDNS. That you can do separately, that part over there. It doesn't have to be like this. I've got it in as a container at the moment. Then the other important aspect of this really is where you're going to be setting up your subdomain names. You're going to, the trick really here is, instead of pointing it to a public IP address as it requires, you can put another subdomain name in, which will resolve, and what it does is it returns the public IP address. So guess what we're going to do? All you put in is your DuckDNS address, and I'll show you quickly what mine looks like. Then what happens is it'll be using the DuckDNS to resolve public IP, and it'll then, again, if somebody types in any of these addresses, it will resolve straight away across to that router and into the rest of the setup over here. So this is what my DNS resolution looks like for my main domain name. This is the domain name I use for home only. I've got other domain names that point elsewhere, but you'll see it's fairly simple. I'm just using CNAME records. You could also make these A-type records. Where you create your new record, you're just going to type in whatever you want the subdomain to be. You'll make it an A or a C type. Priority you can just leave default, and you're going to put in for the value over there, instead of using a public IP, you're going to use whatever your duckdns.org address is, and you'll see same thing over there. There's all the values, and that's as simple as that. That's how you resolve to get a relatively static address, even though your home router might be changing its ISP address. So that's really that aspect over there set up. On your router, the principle you're going to be following here for the router, instead of having all these port forwardings to different places and so on, all you're going to be forwarding is port 80 and port 443, and they will be forwarding to the container's IP address for the Nginx proxy manager. That is all that happens there. Nginx proxy manager is going to be the magic that then picks up what subdomain name is coming through and where does it need to go to, and whether it's another container or whether it's, as you'll see here, I've got separate Raspberry Pis sitting in the house. These aren't necessarily the correct ports here, but I'm just illustrating as well. Each device can have a port 80, or it can have whatever ports on the inside. And by the way, the same goes for a container. It'll have an incoming port and an internal port number that it's actually listening to or making use of. And the Raspberry Pi is exactly the same principle. I think without further ado, I can probably then just dive into the Nginx proxy manager to show then how that is set up. I think if I show you that, it'll sort of make sense how this part of the routing really is working. So again, I'm not going to show how to set up Nginx proxy manager. There are quite a few videos out on the internet that show that already, but I just want to show the concept again behind setting up the proxy, just a point. You'll see if you go to your hosts, or say their proxy hosts, I've got a couple already set up. In your case, you're probably going to have nothing set up. So the important part really is going to be to add a new proxy host. Here, you're going to type in for the domain name is the full domain name that will be resolving what you want to resolve. It's coming in from the internet. So it could be weather.com gadgeteer.za.zo, whatever yours currently is, and you're going to say there add. It has to be the full domain name, not just the subdomain part in the front. You must leave that as HTTP over there, because you'll see now we'll also be able to generate SSL from this, but we need that to resolve. Then the forwarding of the host name or the IP address, this is going to be the IP address of the container you're pointing to, or to that Raspberry Pi or whatever else you've got sitting inside the house. So you'll put your address in there, and it'll be an internal address usually, and the port address. So a lot of them are going to be on port 80. If it's, say, a web service, you could be running WordPress inside one of these containers on a Raspberry Pi, but it could be anything else. It could be something listing on port 3000, for example. Generally, you're going to want to just switch on here block common exploits as well, and you'll usually have this publicly accessible. What it basically means is it'll just immediately forward anything across to that IP and port number. It's not going to challenge the user for anything, but you can alternatively switch on access list controls, and that's going to allow you actually to challenge the person with a separate login ID and password. I'll come back to that just now though. The other important thing is to, if you haven't already got an existing SSL set up, if it's a new thing you're setting up, you're obviously going to say request a new SSL certificate, and you're going to force SSL on, and usually you can enable HTTP2 support, and you must agree to the terms and conditions. I just want to say something about this. There is a little bit of a bug at the moment with Nginx Proxy Manager, in that although you activate these here, when you've said save, it will pull through. You'll see it'll take about 30 seconds to about a minute. It'll pull through and create the Let's Encrypt certificate. But when you open this up again, you'll notice both of these are disabled. All you need to do is open it up, enable them again, and save again. That's the important part there, really. I'm not going to generate one here now, but just to say that that's how it happens. What I can just mention quickly though is the access lists. So I've set up access lists here just really by way of testing, but what you'll do is you'll just give your access list some or other name. Say it's me only. Just whatever the something that that describes what you're looking for. Then the next step you're going to do really is, if you want to put, there's two options here. Authorization, where you can just give a username and a password there, or you can have an access list if you want to restrict the login to just specific IP addresses. But just remember, these have got to be public IP addresses, so not your internal addresses. So you're only going to use this really if you're coming in from another fixed IP address from work or some other place where you know what the IP address is going to be. That's not always maybe the case. So many people might want to use this. You don't need these access control lists or authorizations unless you want to put an additional validation step between the external person coming in and your web service or your service on the inside. So don't think of these as mandatory. I'm just saying these are optional. If you've filled one or both of those in, you can say satisfy any, which will mean either it matches that public address, no password needed, or if you haven't got, it'll ask for a password and an ID if it can't match the IP address. Obviously, if you've got that, it's got to satisfy both. Be careful of this, because if you don't have the IP address, you're going to lock yourself out. So generally, you might just want to have either satisfy any on or have that as blank. The other option here, I've not tested this to get it to work yet, but pass the authentication through to the host. So what would happen there really is, if you use the same ID and password as the service that you're looking for, then what will happen is it should pass those authentication details through and log you straight into the service. So there's just one other little glitch here as well, as a matter of interest. Once you've created this, or you've made any changes in your access list, one thing you do have to do, it won't register or take, and that confused me a little bit. You just need to reopen whichever the service is that you've put the access list in, and just save it again. That seems to be, it needs that step just to refresh it. So that's also something that puzzled me a little bit. So that is pretty well much that as to how Nginx Proxy Manager really works. You'll see here are the various services you've got set up, and you'll see also if you look at the addresses here, these addresses where I've got the 2112, these are actually all pointing to, there's a couple of them, they are all pointing to my Open Media Vault service, and these port numbers are the containers that were set up to listen to a particular external port address. If I had to look here, Open Media Vault itself is listening to port 85. My RSS reader is listening to port 3288. Remember, inside the container, it might very well be working on port 80 or whatever. It doesn't really matter. This is just to say what it needs to point to so that it can pass the query through to the right service. Yeah, in essence then, Nginx Proxy Manager is not only doing all this routing, it can do an additional step of authentication, and it's also very easily helping you set up and manage all your Let's Encrypt SSL certificates. There you can see them all at a glance, when they expire, and I think you've got options here to renew now or to delete them and so on as well. So if I just go back to that diagram over here again, you'll see there in Nginx Proxy Manager where we were pointing to a particular service, we were using an IP address with a port number. Okay, I'm using slightly different ones. These weren't actually my real IP addresses, but just by way of example, you'll see that that was how we were pointing to the containers, and as I said, we were using the actual IP addresses of the various Raspberry Pis with their whichever port number that I was originally forwarding to. You'd be using the same thing. So Nginx Proxy Manager really gives you one easy place to manage your SSL routing through to the services. What's also nice is you can just disable services on the fly and enable them again if you want to, all in one place, without having to mess around with all the individual settings on the router. So yeah, I hope that wasn't too confusing for everybody. I was really just trying to give a very high level conceptual overview of how you could use DuckDNS to get your static IP address and use something like Nginx Proxy Manager to easily manage all this routing, SSL certificates, and so on from inside your network. I will add just 1 or 2 or 3 links below my video just for some of the videos that did help explain some of the individual concepts to me, and those might be of use to people. But like I say, there's no one recipe that fits everybody. You don't have to use Open Media Vault. You can be using other alternatives as well. So that's basically it. Hope people found it enjoyable and of some interest, and hopefully of some use to you if you want to set up multiple services inside your own home. And keep safe and well out there, and I'll see you in the next video.